Assalamualaikum and a very good day everyone. My name is Nurul Ain binti Yazid, final year student in Chemical Engineering UiTM Shah Alam, and I am excited to share with you my research on the physical-chemical characteristics of food waste charcoal briquettes using natural binder. Under the guidance of my respected supervisor, Associate Professor IR Dr. Siti Shawalia Idris, and with the honor of having Dr. Jeffrey Jabbar as my examiner. In this presentation, the goal is to discover sustainable solutions within the field of solid waste management. The global phenomenon of wasting 1.3 billion tons of food each year is both concerning and troubling. These numbers highlight an urgency for action and systematic change. Therefore, utilizing food waste to produce charcoal briquette is an unconventional solution to address this essential global concern. Food waste, comprising organic materials like leftover vegetables, meat, and chicken bones, serve as the primary raw material for the production of charcoal briquettes. There are two methods highlighted in the manufacturing technique of conventional charcoal production and microwave pyrolysis. Microwave pyrolysis method offers the advantage of faster processing times and potentially more controlled conditions. Thus, this method is the most effective method in food waste charcoal briquettes manufacturing. Aside from that, the binder has been developed as a result of prior research and has been recommended for use an alternate method for improving the quality of food waste charcoal briquettes. Each binder will be combined with the charcoal briquettes of varying concentrations, allowing for the determination of the chemical and physical properties of the food waste charcoal briquettes. My research project begins with a fundamental question. What is the problem I aim to address? In my case, I am confronted with three problem statements, which are three value, which are known as conventional techniques for charcoal briquettes manufacturing, contributes environmental impacts, lower caloric value, with consequently contributing to a reduction of overall energy content in charcoal briquettes with the use of unsuitable binder, as well as reduction in the hardness of charcoal briquettes due to the lower concentration of binder. Thus, by identifying these three problem statements, it serves as a guiding force for the entire research process. The objective could be determined once the problem statements have been determined. There are two primary objectives in this research. The first objective in this study is to investigate the effect of different types of binder, in which banana peel and used cooking oil, on physical and chemical characteristics of food waste charcoal briquettes. And the second objective is to determine the impact of binder to food waste ratio of 1%, 5%, and 10% on the physical and chemical properties of the charcoal briquettes. Now, let's proceed to scope of research. There are three scopes of research. The first one is focused the time frame of collecting food waste from a nearby cafe. This time frame is essential to safeguard the freshness and quality of the collected waste. The waste collection will primarily target pre-cooking waste generated. Second scope is specifically concentrated on utilization of binders with a focus on banana peels and used cooking oil. The sourcing of these binders involve collecting banana peels and used cooking oil within the same area, with strategically planned with 2-day time frame. And then the last scope is a comprehensive analysis of charcoal briquettes. Could come across limitations due to the detailed composition of the raw material. The procedural sequence commences with the preparation of raw materials. Following preparation, the carbonization process is initiated, employing microwave pyrolysis techniques. Subsequently, a grinding process is applied to reduce the size of charcoal briquettes into smaller particles. The preparation of binders as well as the mixing process demonstrated to enhance the structural integrity of charcoal briquettes. Moving forward, the briquette process shapes the briquettes into cylinders with specified dimensions using a 20-ton molding apparatus. Subsequent to shaping, the briquettes undergo open drying process lasting 2 days and food waste charcoal briquette is done. chemical characteristics of food waste charcoal briquette is shown in table. The raw food waste charcoal contains considerable amount of volatile matter, 45.5%, and the moisture content 5.6%. The moisture content of the raw food waste charcoal has the lowest compared to those mixed with binders, can be attributed to the hygroscopic nature of the binders and their ability to retain moisture. The mixture of food waste charcoal with 1% used cooking oil exhibits the highest volatile matter content, as used cooking oil is rich in triglycerides and free fatty acids. In summary, the mixture of food waste charcoal with 10% used cooking oil generally yields lower ash content and higher fixed carbon content, which lead to more effective additive in the food waste charcoal briquettes. For combustion characteristics, food waste charcoal mixed with 10% used cooking oil demonstrate more stable combustion characteristics compared to the samples mixed with banana peel. Food waste charcoal mixed with used cooking oil samples exhibit a consistent and less pronounced decomposition method in 200 degrees Celsius to 400 degrees Celsius range, indicating a more controlled and stable combustion process with fewer volatiles. This stability suggests that used cooking oil, in which acts as binder in the food waste charcoal briquette, is preferable for applications requiring steady and reliable combustion, making it the better choice for optimized combustion characteristics. Based on the calorie analysis, the caloric value of raw food waste charcoal briquettes lower than mixed food waste charcoal due to the enhanced combustion properties provided by the binders. The caloric value rises with an increase in the binder composition in food waste charcoal. The caloric values of used cooking oil at 10% gives a higher caloric value than a mixture of food waste charcoal with banana peel. Used cooking oil is rich in fats and hydrocarbons, which inherently possess a higher energy density compared to the primarily cellulose-based composition of banana peel. Thus, used cooking oil are deemed suitable as binder for food waste charcoal briquettes due to their potential to increase the briquette's energy content. According to moisture content analysis, raw food waste charcoal generally exhibits the least amount of moisture. This is because raw food waste charcoal undergoes carbonization directly without introducing additional materials. The mixture food waste charcoal with 1% used cooking oil has the lowest moisture content among the food waste charcoal mixture samples with banana peel. However, the mixed sample with 10% banana peel exhibits the highest moisture content due to banana peels have different carbonization characteristics. In summary, food waste charcoal mixed with used cooking oil offer more advantages in producing higher quality charcoal with better fuel properties, which possibly due to its lower moisture content. For compressive strength analysis, raw food waste charcoal has the lowest compressive strength with 0.25 MPa due to the lack of binders that enhance structural integrity. This implies that the addition of binder enhances the compressive strength of food waste charcoal by improving addition between charcoal particles. A briquette containing 10% used cooking oil achieved the highest compressive stress of 1.09 MPa over other meat samples, as it interacts with the charcoal particles to form a cohesive framework that strengthens the material structure. Throughout this study, the briquette sample containing 10% used cooking oil is the optimal mixing ratio of producing high-quality briquettes. For impact-resistant analysis, raw food waste charcoal exhibited the lowest shattering index at 10.34%. This mixture containing various proportions of binders exhibited higher shattering index due to potential variations in binder distribution and also binding strength. The briquette samples with 1% used cooking oil show the highest shattering index at 14.5%, which exceeding the shattering index of the other mixed briquette samples. The highest shattering index was observed in the briquette sample containing 10% banana peel. When evaluating both binders, it became evident that banana peel possesses a great ability to withstand forces that may cause a binding substance to break apart. In conclusion, this study has demonstrated the feasibility of converting high moisture food waste, specifically utilizing banana peel and used cooking oil into useful charcoal using microwave pyrolysis techniques. This study emphasized the importance of binders in the production of quality charcoal briquettes, focusing on their chemical and physical properties. Use cooking oil at 10% concentration excel in physical characteristics in which providing the highest compressive strength due to its reduction in porosity. Therefore, use cooking oil which as binder considered to have better chemical and physical attributes, which is necessary for producing high-quality charcoal briquettes compared to banana peel. Based on the findings of the study, it is recommended to further explore and optimize binder combinations for food waste charcoal briquettes. Specifically, future research should focus on identifying ideal proportions of used cooking oil and other binders to maximize calorie value and compressive strength. Additionally, conducting environmental impact studies of charcoal combustion process will be crucial to ensure sustainable production practices. This approach will enhance the efficiency and also quality of charcoal briquette production and also contribute significantly to waste management strategies, as well as development of renewable energy sources from food waste.